So noon is what I'm going to do, AB.
All right.
I think we're going.
Great. We are good. Let's get started. So we are on page 295 in your notebook. And I'm just popping up to share my screen with you guys. Hopefully it's coming. That's not the right one. I mean, wouldn't you want that one? This one. Okay, so hopefully you guys can see that we're on page 295. We are jumping one lesson. So this is a few pages past where we left off before. We're jumping over to solving trigonometric equations, and we should be ready to go. Here we go. So we're going to start by verifying that the x value actually works in the equation. I'm sorry, let me just adjust a little bit. That's better. Okay, so we're going to start and just do them one at a time. So I'm going to plug in my x value and just make sure that it works. So I have 2 sine of 7 pi over 6 plus 1 equals 0. And then in order to solve this, I'm going to need to figure out what sine of 7 pi over 6 is. And I realize I put in my unit circle, but it's too far away. Here we go. So I jumped right away. That was sine of 7 pi over 6. So here's my unit circle. For a sine value, I'm looking for the y value, because sine goes with y. Here's my 7 pi over 6 right here. And the y value would be negative 1/2. And so I'm going to jump back to where I was. And I have then 2 in the front. Sine of 7 pi over 6, we just found the answer is negative 1/2. And then plus 1 equals 0. Then if I make this 2 in front a fraction, you can cross cancel if you're comfortable, or just multiply straight across. I'd get negative 2 over 2 plus 1 equals 0. Negative 2 over 2 is negative 1 plus 1 equals 0. And what do you know? 0 equals 0. It works. So I'm going to do that same thing now with the 5 pi over 3. So I have 2 sine 5 pi over 3 plus 1 equals 0. Excuse me. And so then I'm going to look at what is the sine of 5 pi over 3. So I'm going to jump. I apologize, I didn't have it as handy as I wanted there. All right, so 5 pi over 3 is going to put me all the way down here in quadrant 4. There's 5 pi over 3. And I need, once again, I'm doing sine, so I want the y value, which is going to be negative root 3 over 2. Okay, so I have 2. Mrs. Bauer, did I miss something? Or is it not supposed to work?
It's not supposed to work.
Okay, great. That's fine. I was like panicked for a second. This is not going to work. I'm sorry, guys. Okay, so if we look at this, if I do the same basic steps, put a 1 under my 2, I can, again, cross cancel, or I can multiply straight across. I'm going to do multiply straight across again for a quick second. And when I do this, negative 2 divided by 2, those are going to cancel. I have the negative square root of 3 plus 1 equals 0. That's not going to be true. Negative square root of 3 plus 1 does not equal 0. So this one is not a solution. So it said verify, so this one would just be not a solution. Sorry, I just panicked because I was like, it doesn't work, but that's okay. It said verify if it is, so we're all right.
Not supposed to work, so we're good.
That's right. All right, so on to number 2. Same kind of thing here. Before I jump into this one, though, I want to remind us about what this little squared means. And I'm going to rewrite this equation actually to help us out. That squared really means my equation says 4 times sine 2x squared minus 2 equals 0. So that squared really means that I'm squaring the sine function, which is sine of the angle. So writing it this way is going to be a little bit more helpful when we're plugging in. I just don't want us to get confused about what gets squared. So when I do that, I'm going to start with my first x value, the pi over 8. So I'm going to say 4 sine of 2 times pi over 8 squared minus 2 equals 0. So you can see there's a lot happening there. All right, so I'm going to go to my inside most parentheses. I have 2 over 1. This time I am going to cross cancel to kind of save me some time. So 2 goes into 2 once and 2 goes into 8 4 times. So I have 4 sine of pi over 4, that's what's left over from that multiplication, all that squared minus 2 equals 0. All right, so then I need to know what sine of pi over 4 is. So I'm going to jump to my unit circle again. I'm looking for pi over 4. Here it is. Up here. Sorry, I should have erased my previous work there. All right, so pi over 4, the sine would be the y value. So I'm looking at root 2 over 2. Okay, so I have 4. Sine of pi over 4 is root 2 over 2. And then I'm going to square that. Minus 2 equals 0. All right, so when I square it, make sure that we square the numerator and denominator. So I have 4. Square root of 2 squared is 2. 2 squared in the denominator is 4. And then minus 2 equals 0. All right. Then once again, I'm going to put a 1 under my 4 in front. And you could cross cancel. I think I'll go ahead and cross cancel. The 4's cancel out. So I end up with 2 over 1, or just 2. 2 minus 2 does in fact equal 0. So we're good to go. All right. Then we're going to try it one more time. We'll see if this one works out. 3 pi over 8. I'm going to use that same rewritten equation. So I'm going to say 4 times sine 2 times 3 pi over 8 squared minus 2 equals 0. So again, a lot happening there. Okay, so then I'm going to simplify my inside most parenthesis business there. So I have sine, then I'm going to put 2 over 1. 2 goes into 2 once, 2 goes into 8 4 times. So I end up with 3 pi over 4. Great. I feel like I'm going like super fast. Maybe I'll pause for a second. Mrs. Ballard, how are you today?
I'm good. How are you?
I'm good. Actually, selfishly, I just wanted to drink a coffee. You know,
well,
what are you going to do? All right, so let's jump to the unit circle. We're going to look for 3 pi over 4. All right, so 3 pi over 4 is over here in quadrant 2. I'm looking for sine, so I need the y value. And that's, by the way, reminder over here, we have cosine, remember, is x, and sine is y over in the corner. All right, so I need the y value, which is root 2 over 2. I'm going to hop back over here. I have 4 times root 2 over 2 squared minus 2. At that point, hopefully you notice this equation and this equation, they're the same. So I'm going to end up getting the same result. And I could go through and show all those steps, but I'm going to say, hey, guess what? Those are the same, which means their answer is the same. So 0 does, in fact, equal 0. Any questions or concerns before we move forward?
I think we're good.
Awesome. All right, so now we're going to look for all the solutions of the equation in the interval 0 to 360. I want to remind us about this notation. The bracket means that we are including 0 as a possible answer. The parenthesis means up to, but not including 360. So we could have 359, but we can't actually use 360. We've seen that before. Just a quick reminder since it popped up what those mean. So starting at 0 up to 360 degrees. All right. So this says cosine of x is negative root 3 over 2. We want all the solutions. Even though this says x there, remember it just represents an angle. Our cosine goes with the x value in our unit circle. So I'm literally going to go grab the unit circle and I'm going to look for negative root 3 over 2. Before I do that, I'm going to be a little more strategic, and I'm going to remind us that all students take calculus. And this is cosine. It is negative. So I need to know, question for the chat. Which quadrants will cosine be negative in?
So we need to know which quadrants will cosine be negative in the chat.
And I get a coffee break.
I just wanted more coffee.
Miss Ballard knows me so well. I had a late start this morning, so I haven't had coffee until right now.
That's okay. I had an early start. I've been up since 3. I even took a nap.
All right, guys, what do we think? Which quadrant or quadrants will cosine be negative?
I still don't have anything in the chat, Miss Rondo.
Is my class still winning?
I'm looking right now. 1, 2, 3, 4, 5. Yes, your class is still winning by 1, I believe.
By 1. Okay. Well, this is ridiculous, guys. Come on. You can
Oh,
figure
oh,
it out.
Cynthia, in Roman numerals says 2 and
Oh,
3.
2 and 3.
Cynthia,
I
you
will
have
take.
passed. You can go to my class next year.
Yes, 2 and 3. Remember, the letters stand for the A is all trig functions are positive. S is sine is positive, which also means cosecant. T is tangent is positive or also cotangent. And C is cosine is positive. So the all students take calculus, just a reminder, it tells you where it's positive. So we want the places it's negative. So not the all and not the cosine. So it would be quadrants 2 and 3. All right, so I'm going to jump to my unit circle. Quadrants 2 and 3, I'm looking for, I'm sorry, I forgot what I was looking for, an x value that is negative root 3 over 2. So negative root 3 over 2, I found one right here. Negative root 3 over 2, I see one right here. Then I'm going to grab the angles that go with them, and I'm going to list them as my answers. So, whoops, not the next problem, sorry. So the answers for x would be 5 pi over 6 and 7 pi over 6. Ah, Mrs. Ballard, what did I do wrong?
Example 3.
I didn't. Or students, can the students catch me first before Mrs.
Oh,
Ballard?
I know what you've done wrong technically.
It's not really wrong. It just didn't answer the question properly.
No, it did not.
That's okay. I don't want to spend a ton of time on this. So if you guys see it, that's great. If not, my answer interval was given in degrees. So my answers should be listed in degrees. So even though those are correct answers, they are not in the correct unit. So if I go back, this particular circle does not have my degrees on it. So I would need to either figure out what it is just by figuring it out, or I could change these by multiplying by 180 over pi. Remember, that's how we translate back into degrees. The way that I prefer to, what I said, just figure it out, is I can take pi. I know pi represents 108. Pi and 180 are the same. If I take pi, 180, and divide it into 6 pieces, or my pi over 6 portion is 30 degrees. It's a 30-degree angle. And then this says I have 5 of them. And again, this is just my own brain. If this does not make sense to you, please just do multiply by 180 over pi. It's totally fine. So I would do 5 times 130 in my head really quick, and I'd say, oh, this is a 150-degree angle. And then the same kind of thing, pi over 6 is a 30-degree angle, and I have 7 of them. So that would be 210 degrees. And again, if that little method doesn't work or it confuses you, please just stick with multiply by pi over 180. It won't fail you. All right, so the answers, because our interval said degrees, our answers need to be in degrees. All right, let's look at number 4. So this one says tangent x equals -1. Because I typically want these to be fractions or ratios, I'm going to go ahead and put this over 1. I'm going to remind you that tangent of any angle is y over x. So typically we're looking at the x and y value. If I look for -1 and 1, specifically on my unit circle in my numerator, if you look at all those numerators all the way around, no pair says -1 and 1. So we have to have a different method. If none of those match, we have to be able to still figure this out. So if you think about where this came from, -1 over 1, I could rewrite that fraction as -5 over 5, and that would be equivalent. Or I could make it -37 over 37, or I could call it -1,000 over 1,000. I can make it any two
Negative
numbers.
smiley face over negative smiley face.
Oh, I like it. Negative, how do you do negative smiley face over smiley face? Okay,
There
so
you go.
Mrs. Ballard is right on track here, because it doesn't matter what the two numbers are. As long as the numerator and denominator, the actual numbers match, I'm going to end up with -1 over 1. It's going to reduce to the same thing. Or as I like to say, it is same over same. It's very technical math speak right there. Same. So if I use that to help me out on my unit circle, I'm going to look for an X value and a Y value that are the same. Before I jump into that, I'm going to still be a little more strategic. All students take calculus. This is negative. So here we go for the chat again. I need which quadrants will tangent be negative in?
All right, so in the chat, tell me, Roman numerals gets you bonus points. Where is tangent negative? Quadrant 1, quadrant 2, quadrant 3, quadrant 4.
And I got a little more coffee too.
Cynthia's on it again. She really has passed the test. She does get to go to my class next year. She says 2 and 3. Sorry, 2 and 4 in Roman numerals. I read it wrong.
2 and 4. Awesome. So the places it would be positive. We don't want the positive. We don't want the all, and we don't want the tangent. Those are the positive places we want where it's negative. So that's quadrant 2 and quadrant 4. So when we go to the unit circle now, we're looking at quadrant 2, quadrant 4. We're looking for same. So in quadrant 2, I'm looking for specifically numerators, but the whole thing, same. I see that here. Everybody see this one, how those are same. I do have the negative. That's okay. We want it to be negative. So same. And then I'm going to look in quadrant 4. And once again, I see same. And again, we do still see that negative, but remember, we wanted that. We wanted a negative involved in our problem. And so then if I rewrote those two as y over x, just to prove it to you, this would be square root 2 over 2. That's my y over negative root 2 over 2. That's going to reduce to negative 1. And the same thing here, if I did the y value over the x, again, it reduces to negative 1. All right, so we found our angles. They are here at 3 pi over 4 and at, actually I want to box them, 7 pi over 4. But again, I believe the question we're on, and I'll go back and check, asks us for these in degrees. So we're going to need to put those in degrees. So it was, 3 pi over 4 and 7 pi over 4. But again, we want our answer in degrees. So quickly, in my head, I would do pi over 4 is a 45-degree angle, and I have 3 of them. So I believe that is 135 degrees.
Correct.
And then pi over 4, again, is a 45-degree angle. I have 7 of them. That one, I believe, is 315.
Correct.
There we go. Actually, I didn't. I said that's what I was doing, but really I did it a different way, but we won't go into that. Shortcuts, when you do it a bunch of times, you find shortcuts because those are really big numbers to multiply. I don't want to work that hard. Some other time, if you want to know, ask me later. Send me an email. Okay, that finishes number 4. Let's move on to number 5. Find all the solutions of the equation in the interval 0 to 2 pi. So this is basically the same thing. Again, we have our closed interval, our open interval, meaning we include 0, but not quite 2 pi all the way up to it. This time we're doing radians. Hooray! Same basic thing. I have sine, so I want the y value, and I'm looking for square root of 3 over 2. Let's, I'm sorry, before we jump, double check all students take calculus. This time I'm going to scoot through it quickly. We need sine to be positive, which is going to be quadrants 1 and 2. So I'm looking for root 3 over 2 in quadrants 1 and 2 in the y spot. Root 3 over 2, quadrant 1, root 3 over 2, quadrant 2 in the y spot. My angles are going to be, looks like pi over 3 and 2 pi over 3. Oops, wrong way. So I would say x equals pi over 3 and 2 pi over 3. Okay, and then let's jump to the last one of that section. This one, actually, I didn't do this on the others, but I do want to remind us one other thing that we talked about a while ago. I don't want you guys to forget. To solve for that x, which is essentially what I'm doing, I'm just kind of working it backwards. But to technically get to the x, I have to undo the secant there. Excuse me. To undo the secant, that requires doing the inverse. So actually what I'm doing is secant inverse of secant x equals, and actually, that's all right. No, it's not. Sorry, I don't want my parentheses quite like that. Woo, okay. So secant inverse of secant x equals, again, I have to inverse both sides. And this would be negative root 2. Actually, I do want my parentheses there. It's just, I can't make up my mind. Okay.
So
go ahead, Mrs. Ballard.
Yes, parentheses where you're putting them, or brackets, doesn't matter. But I'm really glad you're showing that, because this was a huge weakness going into this year's calculus group. So you guys who are here and learning this are really getting ready for next year.
Yeah, I'm sorry, Mrs. Ballard. It dawned on me, hey, we should show that. So
it's okay. I was going to pick it up. So
there you go. I appreciate that. So I do want you guys to remember that that exists. Just like Mrs. Ballard said, it is an important skill. Then what happens is our inverse secant kind of undoes, or it's the inverse, obviously, inverse of secant. So we are left with x equals secant inverse of negative root 2. So that's what we're really doing, is we're taking this and then working ourselves backwards. So this, if you were doing it on a calculator, that's how you would do it with the calculator. With our method here using the unit circle, I'm going to turn this into my fraction. So I'm looking for the secant. I want to remind us that secant is the reciprocal of cosine. So if I'm using my unit circle, it's a little easier to work in terms of cosine. So this would be the same as doing the reciprocal like so. So secant, I took the reciprocal business here, which is maybe a little weird for you, but that's essentially what we're doing. We're looking for when the cosine is 1 over square root of 2. Before I do that, let's double check. Are all students take calculus? I want cosine to be negative, so I don't want the positive places. That means I'm in quadrants 2 and 3. Now, when I go to look for this, remember cosine is an x value, and I want it to be 1 over negative square root of 2. When I look for that, I don't see 1 over negative square root of 2 at all. What did I do wrong?
Oh, no.
Apparently, Mrs. Rondeau can't teach math. She doesn't know. She does it all wrong. Can anyone help me out in the chat? What did I do wrong? There's no 1 over square root of 2.
Any ideas of what it could be? Why we're not seeing 1 over square root of 2 in the unit circle? Put it in the chat. Very quiet today, Miss Rondeau.
It is. We're just trying to survive until the end of the year, I think. We're almost done.
We've only got 1 more day.
Only 1 more.
Because we're virtual, so we get to let you out a day early.
That's right. Well, and I don't want to hold us up too much on this. If we're not sure, that's okay.
Wait, you got one, Marilyn.
Marilyn says
square root can't be at the bottom.
That's right.
Marilyn, you get to go to my class next year.
We don't want that square root in the denominator. So we would have fixed this by multiplying top and bottom by square root of 2 and gotten square root of 2 over 2 with that negative still in front. So this is what we're actually looking for, because it's not rationalized if we do 1 over root 2. So we fix it up. Then if we go look for an x value that says negative root 2 over 2 in quadrants 2 and 3, we should find that. So an x value in quadrant 2 and 3, that's root 2 over 2, and it's negative. There we go. So now we have found it. We're looking at 3 pi over 4 and 5 pi over 4. I'm going to jump backwards. Excuse me. All right, so we have x equals 3 pi over 4 and 5 pi over 4. And we have completed that problem. All right, good job, guys. Let's keep going. We're going to wrap it up with my time with you with number 7. This one says solve the equation, and it has plus or minus 2 pi n. So I'm going to come back to that in a minute and talk about why we're going to do that plus 2 pi n. I'm going to start with just solving the equation. So if I'm going to solve this equation, even though there's a sign in there, I just pretend like it's just like x. So this whole little expression, sine x, is basically just going to act like my variable. Since we already have x, I'm going to just call it a. So really, I'm solving 2a minus 1 equals 0. is essentially what I'm doing. It looks different. It has the sign X, but it's the same thing. Okay. So if I was solving that, I would typically start by adding 1 to both sides. So I'm going to do that same thing, and I'm going to add 1 on both sides of my equation. Sorry, that's not very clear. That's 2 sides. And I end up with 2 sine X equals 1. And then if I was going to continue solving, I would divide both sides by 2, and I would get sine X equals 1/2. Then to continue my nice algebraic solving skills, to undo the sign, I would inverse it. Both sides. And that would give me X equals sine inverse of 1/2. And then I would again be using my unit circle. So I'm looking for a Y value that's 1/2. And I'm going to really quickly, all students take calculus. I know that that's going to show up. Positive sign is going to be in quadrants 1 and 2. A Y value that's 1/2. Let's see what we have. Y value of 1/2, I see it here. There's quadrant 1 and there's quadrant 2. So I have pi over 6. And I have 5 pi over 6. Awesome. I'm going to go back and I would say, okay, my answer is pi over 6 and 5 pi over 6. So the issue here where it said solve the equation is it just said solve. And we learned once upon a time, and I'm going to actually draw this for a second just to illustrate why this works. It said solve the equation. It did not give us any parameters. The previous ones, they told us do it within, like right here, from 0 to 2 pi. That's 1 circle. This question just says solve. It doesn't tell us where, if we do 1 circle, if we could do 10 circles, or whatever. So if I build myself a circle really quickly, that's pi over 6 angles. Back to drawing. I love that. Don't mind my fabulous, perfect pi over 6 angles. And I'm going to highlight for us the 2 angles that we're talking about. Actually, I'm going to start with pi over 6. So pi over 6 would be this one right here, this first one. That's my terminal side of pi over 6. And so I know that this angle is a solution. However, this is not the only place that I can stop. This is not the only angle that has a terminal side at this location. I could do my coterminal angles and I could go, okay, I go all the way around the circle and then stop. And I'm at the same terminal side. Or I could go around the circle 2 times and then stop. So we're back to remembering that the circle, you can go around that circle as many times as you want. So rather than drawing a picture that would go on for infinity, trying to draw all the possibilities, we use this fabulous little thing, which the 2 pi represents, that's 1 circle or 1 rotation. And then the n represents the number of times. So that's basically our way of saying, hey, I'm going to go around the circle 2 times, or I'm going to go around the circle 5 times. And so by saying plus or minus, the plus is going in a positive direction. I went around the circle positively 2 times, 3 times, 5 times, whatever. And then the negative is just, again, that idea that we could, in fact, go backwards. So we could start here and go this way around as many times as we want and end at that same terminal side. So instead of, again, drawing a crazy picture that would take forever, we say this. We say x can equal pi over 6 plus or minus 2 pi n. So pi over 6 plus however many circles you want to go in the positive direction, or minus however many circles in the negative direction, or x could equal 5 pi over 6, and we do the same thing, plus or minus 2 pi n. And that is where I'm going to stop. And do we have Andy ready for joke of the day?
He is sitting here ready for the joke.
Okay, let me get rid of this so we can see him.
Yeah.
All right, here we go. Okay, Andy, what's your first joke?
So,
You don't remember?
oh my gosh.
He apparently has forgotten the joke.
Oh no.
So
Technical
I will
difficulties.
start presenting my screen while he is looking up the jokes.
Okay. We need the joke of the day. It's important.
I know. We will not be without the joke of the day. He just forgot his jokes of the day. All right. Are you seeing my screen, Miss Rondo?
Yes, we are.
Okay. So I'm starting with example 9. We're skipping over example 6. He says he's ready.
I'm ready.
Okay.
Here we go.
I'm ready.
Okay. Tell us the joke.
So, how do you know how many protesters are at a rally?
I don't know. Do you know how many protesters are at a rally?
By using a radical function.
By using a radical function. Oh.
Radical.
All right, Andy, what's the next one?
How do you know that? Oh my!
He forgot that one. All right. Gotta love 8-year-olds. Okay. We are going to start example 9 here. All right. We'll see how far we can get in the next about 20 minutes. He's back. Hurry, tell us.
How do you know that factorial is excited?
I don't know. How do you know a factorial is excited?
It's always excited.
It's always excited at what?
Is
Is it something without an exclamation point?
Yes. Because it has an exclamation point.
Oh, it's always exciting because it has an exclamation point. All right.
Very good.
Go. All right. He did. He's like, I got to memorize these, and he didn't quite get it down. All right.
Not quite.
Yeah. All right. So we're going to
stole so much time. Go.
Through example. Are we? So I'm sorry. I didn't mean to interrupt, Miss Rondo.
No, I just said I'm sorry. I stole so much time. I took a little bit of extra on some of them.
No worries at all. Because if we don't get through all these today, we do some tomorrow.
That's right. Or we skip some. It's all good.
Or we skip some. Yeah, because I think example 9 and 10 are almost identical here. So
yeah, I think you could probably skip one of them.
Yeah, I'll probably just do 9. So
because it has sine, it's better.
Yes. Okay. All right. So I want to, just like Miss Rondeau was just talking about, this is just like an algebra equation. This is like saying x plus square root of 2 equals negative x. So I want to combine like terms. So my trig is going to act like a variable. So I'm going to add sine to the other side. So I know I have sine plus sine would be a coefficient of 2 sine x. And this is not a variable, so I'm going to move it to the other side. So it's negative square root of 2. And then I want to get everything off of my sine or my variable before I can solve for it. So I'm going to do sine of x equals negative square root of 2 over 2. Hey, Andy, can you shut that door, please? Okay. Now he's being noisy in the other room. All right, now I want to undo or do the inverse of sine to get this x that's inside of here that's trapped in there out. So what I'm going to do that is I'm going to do the sine inverse, or I can write the arc sine. Oops, I'm writing arc sine, but I'm not supposed to be. Or I can do the arc sine of that instead. So I'm doing the sine inverse of negative square root of 2 over 2. Okay. So we know that these guys would cancel, and I just get x equals sine inverse of negative square root of 2 over 2. And what I am looking for is a radian measure. And what's really nice about these is Mr. Rondeau just showed you that you had to add that 2 pi n to it. Well, they have the domain restriction on here that we only have to go between 0 and 2 pi. So we don't have to do that extra little business, okay? So always look for this. Typically, when we're talking AP calculus, it's only ever between 0 and 2 pi. You never have to do the extra stuff, okay? All right, so I'm going to go to my unit circle. I know that sine is the y value, so I'm going to look around my unit circle for everywhere where the y is negative square root of 2 over 2. So I do this a little differently than Ms. Rondeau does. So you get to see 2 techniques today. So I'm going to go look for my y value anywhere that's negative square root of 2 over 2. I notice a square root of 2 over 2, but it's not negative. I notice another square root of 2 over 2 in the y, not negative. Oh, there's a negative 1 there. So that means I want to write this radian measure as one of my x's. So x equals 5 pi over 4. And then I'm going to go all the way here to this one. Oh, look, there's another one. And it's 7 pi over. I just heard a little blip. Do we have a comment that we need to deal with, Miss Rondo?
It was my comment. You're good.
Okay.
It was
All
about
right.
Christmas. Only 212 days until Christmas.
Okay, gotcha. Start
Important.
shopping now. All right, so that's what we've got on example 9. We're going to go ahead and skip example 10 because it's very similar. And I'm going to do example 11. So I'm going to add 1 to both. I'm just going to do my algebra. I'm going to, in order. So I'm going to add 1 to both sides. So 3 tangent squared x equals 1. I'm going to divide by the 3. So tangent squared x equals 1/3. I'm going to undo the squared by square rooting. Ooh, and technically when I square root there, I would have a plus or minus in front of it. For my cheat sheet here. Okay. And so I would have the tangent of x equals plus or minus 1 over square root of 3. The tangent's a little bit different. There is nowhere on here where I have 1 over square root of 3 anywhere, nor is there anywhere, if I rationalize this, that I could see 3 over square root of 3 anywhere on the unit circle. So I have to go back to my trig functions or my trig identities. And I know that sine divided by cosine is equal to tangent. So I'm going to use that fact. So the way I develop this is I know that the sine has to have a 1 and the cosine has to have a square root of 3. If you look at your unit circle, what is always, 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 no matter where we're at, on the bottom? Gotta be a 2. Yeah. So I know that I'm looking for 1/2 for the sine and square root of 3 over 2 for the cosine. Remember how we took like a week ago, we took this shortcut where we canceled those things? We're reversing that shortcut right here, okay? So, and if you want to think about it in coordinates, I am looking for where we have square root of 3 over 2, comma 1/2. It doesn't matter if it's a plus or minus. I actually need 4 of them. I'm going to have 4 angles this time. I'm going to invade my space here for 12. So I'm going to take the tangent or the arctangent, or sorry, tangent inverse or the arctangent of both sides. So tangent of x equals, should have done that sooner, but that's okay. Plus or minus 1/2 over square root of 3 over 2. I'm going to do that. So I'm going to figure out what x equals. I'm not going to rewrite that. So I'm just going to go right to my unit circle. And I'm going to figure out from my unit circle where I have the y value, the x value of square root of 3 over 2 and the y value of 1/2. So I'm seeing it here. I'm seeing it here. And we're not worried about pluses and minuses because I get to keep them both this time. And here and here. So, and you notice that they're all the over 6s this time. There's a little bit of a pattern there. So I would write that I have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. I just got 4 answers, 4 angles where that is a true thing. All right. Do we have any questions or comments, Ms. Rondo?
Nope, we're doing good.
Okay, good. All right, I am gonna do number 12. I'm gonna have to scooch some work somewhere. All right, I think I'm gonna squeeze some work in like right in this area right here. Didn't quite plan enough in my notebook, apparently. All right, so I'm going to start by adding the 3 to both sides. So I get 4 sine squared x equals 3. And then I'm going to divide by the 4. So sine squared x equals 3 divided by 4. To undo the squared, we square root both sides. So I write a plus and minus in front. So we get sine x equals plus or minus square root of 3. And then I know the square root of 4 is 2. And yay, I know that is in my unit circle. So I don't have to do any extra weird stuff. I just get to take my inverse of both sides. So to do the inverse of both sides, I take the arc sine or the sine inverse. So that way I actually am solving for x. Plus or minus. And that's what everybody always struggles with this is they don't understand how they got the x where it is. All right, so I am looking for everywhere where the sine is the y value. So everywhere where the y value is square root of 3 over 2. So I'm going to go through all my y values here. So I get square pi over 3. And I get both the pluses and the minuses. So I'm getting that one. And here, ooh, what am I circling now? This. And it looks like this one right here, so I get that. So those are my 4 values that I'm going to write down. So I get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And I know I'm running into my charts here. That's an S from the next chart. All right, we doing all right?
Yep, doing good.
Okay. All right, let me see how we're doing here. Oh, we only really have to go to 15, so we're probably doing okay on time.
I think
We'll
you'll
see how we
make
do.
it.
Well, yeah, I think we'll make it. So, and no one showed up at my front door yet, so we're good. All right, so our goal here is to, when we don't know what to do, try something, okay? I'm seeing something that's squared, and we saw yesterday how we could factor things, so we're going to go for that. Maybe we get it equal to 0, and we can do some kind of factoring here. So I'm going to move this to the other side. So I've got the cotangent of x times the cosine squared x minus 2 cotangent x equals 0. I notice that I have a cotangent of x in both of those, so I'm going to factor it out. So I get the cotangent of x times cosine squared x, and then what would be left here is a 2 equals 0. Now, when we factored and we solved, we used what we called the zero product property. So that's where we can split both of these up and set them equal to 0 individually. So cotangent of x equals 0, and cosine squared of x minus 2 equals 0. I am going to actually I'm going to solve this one first. So I'm going to get this reduced a little bit. So cosine squared equals 2. So I'm adding the 2 to the other side. I'm taking the square root, which is a plus minus. So I get cosine of x equals plus or minus square root of 2. Okay. So I am going to I'm going to do the inverse of both of these here. So I'm going to do cotangent inverse of the cotangent of x equals the cotangent inverse of 0. So these guys cancel. I've got x equals, and I'm going to look the cotangent. Ooh, interesting. I really want the reciprocal of that, which would be, we know that would be, the reciprocal would be tangent. Actually, I don't want the reciprocal. I want cosine over sine, don't I?
Yes.
So I wrote way too small.
That's okay.
Let me find a different color. So we know that this is the cosine and this is the sine. There's always a 1 in the denominator. So I need to look on my unit circle where I have an x value of 0 and a y value of 1. So I'm looking. X value of 0, y value of 1. Ooh, and I don't know if this was a plus, minus. Oh, we don't know what the denominator could be. We could have 0 over positive 1 or negative 1. So I could really have a plus minus situation going on there. So I also get this one here. So those are the 2 radian measures I would get for that part. Why am I writing over 3? It's supposed to be
Because
over
you like
2.
3s?
Apparently today. All right, now I'm looking at the other half. I am needing to find where the cosine is equal, or the x value is equal to just a square root of 2. And if I look at that on the unit circle, on our unit circle, there is nowhere where that happens. So, and then we talked about when we were doing the inverses briefly, that we said that it has to be between certain radian measures, and this just falls outside that domain. So we're going to say that that's an extraneous solution, and we don't have to use that part. So your only answers would be these 2 right here. All right, we're going to try another one. So we're going to do 14, and we're going to probably do 15. Okay, that's our goal for the day. Use a different color. All right, again, I'm going to get it equal to 0 because I really don't know what else to do with that. So if all else fails, I know I can maybe do some greatest common factor factoring. All right, I'm seeing a sine in both of those, so I'm going to factor a sine out. So sine x times, when I take one sine out of here, I have one sine left, so just sine x. And when I take a sine out of the second part, I just have a negative 2. And then I'm going to use zero product property. So sine x equals 0, and sine x minus 2 equals 0. I'm going to do the sine inverse of the 0, because I know for sure 0 is one of my candidates. Sine inverse of 0. So these guys cancel. And we know the sine inverse of 0, we're looking for where the y value is 0. Anytime the y value is 0. So I'm coming here. I see a y value of 0 there. I'm going to search my unit circle for y values of 0. Here's another one, so I get that radian measure, and I'm going to double check. Y values of 0, y, no more. That's it. Okay. Now, technically, we could go back to the 2 pi and let me explain that. So we've got 0 and pi. We talked earlier in the year about what these guys mean. One of them means, so if it's a bracket, it means it's included. It's closed or included. And when there's a parentheses, it's excluded or it's open. So in this case, we would not go back and use 2 pi as an answer. We would just use 0. And I know 0 is not on my unit circle there. Okay, so it's just that. When I go to solve the other one, the one on the right here, again, I get where I need sine or the y value to be 2. There is nowhere on our unit circle where the y value is 2, so this one is extraneous. All right, we're going to do 15, and then we're going to let you out for the day. Okay? All right, so I believe it was yesterday we started playing with factoring these, and I showed you an example where I replaced the signs with x's. So I'm going to do that again. I'm going to use some of my space over here for 16 to do that since we're not going to do 16.
That's an excellent calculus skill too.
What's that?
Substituting things.
Oh yeah, we do solve stuff all the time. You have to manipulate it to get it to do what you want it to do. So I'm going to use, it's a trinomial, so I always start with a magic x, and this may vary. I don't know what Ms. Rondo does with you guys, but I'm going to factor it the way I factor it in my class.
You're good. They've seen it.
Okay, good. Two numbers that multiply to -2 and add to -1 would be -2 and 1. Now, we have a leading coefficient, so that means we have to get out the box. At least that's the way I do it in my room. So I am obsessed with the box. So I put this in the top left-hand corner, this in the bottom right, and then whatever I got in my magic x goes in the other 2 corners. Doesn't matter the order. Then I ask myself, what times what is 2? I know my only answer to that is 2 and 1, so basically I'm looking for the factors of 2. 2 cannot multiply into the 1, but it can multiply into the 2, so it goes on the left side. And then 2x divides into -2x, -1 times. 1x divides into 1x 1 time, and then this is why this is awesome, because I can check it. 1 times -1 is -1. So really what I'm using is these 2 factors, but now I'm going to plop a a sine in there instead of an x when I rewrite it over here. So I've got sine x minus 1 times 2 sine x plus 1 equals 0. And I'm going to use my zero product property again. Sine of x minus 1 equals 0. And 2 sine of x plus 1 equals 0. I'm going to move the 1 to the other side. Here I'm going to, here comes my appointment popping up on my calendar. 2 sine x equals -1. And then sine x equals -1/2. All right, so all I have to do now is my sine inverses of both sides, and then I should have this one pretty much done. So sine inverse of sine x equals sine inverse of 1. So these guys cancel, and I get x equals. So this is meaning I need to go back to my unit circle. I'm going to erase the junk that's on there, so I'm not too much. I'm going to erase the stuff that's there. And then I am looking for everywhere where the y value, sine is y, where the y value is a +1. So I'm seeing a +1 right here. I'm seeing, is that it? Is that the only place? I think it might be. It is. So my only radian measure off of that one is pi over 2. I'm going to do the same thing here. I'm going to do the sine inverse of the sine of x equals the sine inverse of -1/2. And these guys cancel. I'm going to find everywhere on the unit circle where my y value is -1/2. So I'm looking at my y values. I'm searching my unit circle. Ooh, there's one there. So there's one of my radian measures. Here's another one. There's another radian measure. Did I do that right? I grabbed the x value.
You did the x on one of them. That's okay.
I'm going to fix it. I'm looking for -1/2, so nothing in quadrant 2. There's one there, and then, oh, look, there's another one there. Okay, so we've got 7 pi over 6 and 11 pi over 6. So you'll notice that there's always a pattern. Usually they typically have the same denominator. and you're looking for multiple answers. So they sometimes call these multiple angle equations. Actually, no, they don't. There's another one that they call that because we do something else with it. But. All right, I think that's it, Miss Rondo.
I think it is. I think we're good.
Yeah, I'm going to stop sharing. So we will put an assignment out there to probably go out here in just a little while. And then we'll have one more tomorrow. And then that will be it. Okay. And we will see you guys in the fall, happily. Yay.
Yay.
All right.
Enjoy your summer.
Don't forget to hit stop on the record.
Yes, thank you, Miss Rondo, for reminding me. That's not the right button. No, we've got
Good to see all you guys.
Hi.
Win. 1, 2, 3.
Have a great